All right, now's the fun time. We have been working on finding holes, vertical asymptotes, horizontal asymptotes, oblique asymptotes. We're going to add in the x-intercept and the y-intercept, and we're going to sketch the graph of these bad boys. So let's see if we can sketch the graph. We'll move over because I'm going to need plenty of space to write. That I have f of x equals, let's just do something simple, like x cubed minus 8 over x squared minus 4. All right, here we go. First thing you want to do, like I've been saying in all my other videos, factor, 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 factor. Get it fully factored. So we know that my f of x, this is going to be the difference of cubes, going to be x minus 2, x squared plus 2x plus 4 all over, well, this is the difference of squares, gives me x minus 2, x plus 2. All right. So I know I'm going to be looking for any holes that exist. I'm going to look for vertical asymptotes, and I'm going to give myself some room because I'm going to write a vertical asymptote and behavior, a horizontal asymptote if it exists, a slant asymptote. Now, if I have a horizontal asymptote, I won't have a slant. If I don't have a horizontal, I will have a slant. So you won't have both of these. It's going to be one or the other. All right, so the first thing I see right off the bat, I've got something I can take out. I've got this x minus 2 and this x minus 2, so I know x minus 2 cannot equal 0, but because it's removable, it's a removable discontinuity, which is just what we call a hole. Therefore, we know my hole occurs at x equals 2. X cannot equal 2. So I'm going to have a hole at 2. To find my value, I'm going to do f of 2. So let's see, we've got it reduced as x squared plus 2x plus 4 over x plus 2. Let's see if we can do this in our head. 2 squared is 4 plus 2 times 2, which is 4 plus 4. That gives me 12. 12 divided by, well, 2 plus 2 is 4. 12 divided by 4 gives me 3. So I have a hole at 2, 3. That means when I graph it, I'll show you what we have to do. So then my vertical asymptote. So this is my hole right here. So my vertical asymptote, whatever's left after I reduce the fraction, I just set my denominator equal to 0. Well, that's x plus 2. So I know x plus 2 cannot equal 0. Therefore, x cannot equal negative 2. So my vertical asymptote is actually going to be x equals negative 2. It's an equation of a line. Make sure you write x equals negative 2 and just don't give me the number. Now let's do our table and see what's happening around negative 2. So we're going to do the limit as x approaches negative 2 from the left of my function f of x, y. And then the limit as x approaches negative 2 from the right of my function. Horrible plus sign. And we're going to do a table. All right, so let's see. To the left of negative 2 is negative 2.1, negative 2.01, negative 2.001. To the right of this is going to be a negative 1.9, negative 1.99, negative 1.999. And when I do this, I'm going to get negative 42, negative 402, negative 4,002. Those are all rounded numbers. So this is going down, and we know vertical asymptotes are either positive infinity or negative infinity. So since this is going down, this is going to be negative infinity. So I now know as the limit as x approaches negative 2 from the left of my function f of x, it is going to negative infinity. So now we're going to have to do the limit as x approaches negative 2 from the right of f of x. When I do this, the 1.9, this gives me 38 about, 398 about, and 3,900 about. That means this is going to infinity because that number is getting bigger really, really fast. So this means going to infinity. So infinity. All right, let's look at horizontal asymptotes. Well, my degree on top, 2. My degree on bottom, 1. Well, last time I checked, 2 is greater than 1. Therefore, I do not have a horizontal asymptote. So this does not exist, but I do have a slant. So let's find that slant asymptote. All right, to find the slant asymptote, we got to do our good old friend, polynomial long division. We're going to take my divisor, which is my denominator, x plus 2. We're going to take my dividend, which is my numerator, which is x squared plus 2x plus 4. And we're just going to do long division. Let's do it. How many times does x go into x squared? Well, that's pretty straightforward. It just goes in x times. X times x gives me x squared. X times 2 gives me plus 2x. I'm going to subtract the whole thing, and lo and behold, look, x squared minus x squared, that's 0. 2x minus 2x, hey, that's 0. That just leaves me a 4 when I bring it down, so my remainder is 4 over x plus 2. That means my slant asymptote is my parent function of a line y equals x. That's it. Now, we got to find my x and y intercept. If I can find an x and y intercept on this, then I can plot those. I can plot my whole. I can plot my vertical asymptote. I can plot my slant asymptote. And with the behavior around it, the behavior around these, I can actually get a pretty decent sketch of the graph. So, all right. So, if you remember from graphing polynomials, to find my y-intercept, all I do is plug 0 in for all of my x's. So I would have 0 squared plus 2 times 0 plus 4 over 0 plus 2, which gives me 4 divided by 2. This gives me 2. Y-intercept is going to be, when I had a 0 for an x, I have for a y. To find my x-intercept, all I do is I'm going to take my numerator and I'm going to set it equal to 0. Because if I have 0 on the top and a number on the bottom, 0 divided by any number is 0. And that's really what we need to do. So for my x-intercept, I set my numerator equal to 0, which is x squared plus 2x plus 4 equals 0. This doesn't factor, so I'm going to use the quadratic formula. But I always do the discriminant first. The discriminant is the negative, is just the b squared, wow, minus 4ac, because this is going to tell me if I need to finish it and actually get a number, or if I don't even have x-intercepts. So let's do this. So I've got 2 squared minus 4 times 1 times 4. This gives me 4 minus 16, negative 12. This tells me there's no x-intercepts because I'm going to get a complex solution. So there are no x-intercepts of this graph. X-intercepts does not exist. So that's how we find our x and y intercepts. It's the same as a polynomial. We're going to plug 0 in for all the x's and we get our y-intercept. And we are going to get, and we're going to set our numerator equal to 0 to find our x-intercept. Now with that, you may have to use where you generate your list and all that other things, but I'm going to try to keep it pretty straightforward where all you have to do is factor. No promises. All right, I'm the graph. So here's my x-axis, here's my y-axis. Now we are not being precise with my graphs, we are just simply sketching a graph. We know that there is a vertical asymptote at x equals negative 2. So about right here is a vertical asymptote. Now let's label this x equals negative. We know that there is a slant asymptote at y equals x, which is our parent function of a line. Now if you notice I'm using dashed lines because dashed lines represent asymptotes in mathematics. All right, so now I have my asymptote. I'm going to extend this one out a little bit. And this one. Okay, let's graph. I know I have a y-intercept at 0, 2. 0, 2. Call it this. All right, I also know I'm going to have a hole at 2, 3, but I'll deal with that here in a second. Now let's look at how we're behaving around my vertical asymptote. As my x is approaching negative 2 from the left, so as I'm coming in this way, it's going down forever. So it's as I'm coming this way, it's going down. So this horizontal asymptote, or the oblique asymptote, we're going to trace that. We're not going to cross it, and then we're going to go back down. All right. As we're going to negative 2 from the right, we're going to infinity. Know that this is going up like this. We know that this is going to flow, horrible, follow my slant asymptote. So this point right here is going to be 0, 2. That is my y. But I have to account for my hole. That's not going to exist. And the way to do that is to open dot right there, because it's got to be in quadrant 1. And we're going to call that point 2. And voila, there's my graph. That's a pretty rough sketch of this graph. Now, what I would be looking for if I ask you to sketch this is I'm looking that you have your asymptotes labeled with the correct equation. I'm going to look to make sure that you have a hole represented and it's approximately right. Now, if this hole was supposed to be at -2 and you tell it's quadrant 1 to me, that's going to be wrong because you're in the wrong quadrant. I'm looking for your y-intercept, if you have one, to be labeled, and any x-intercepts that you have to be labeled. But this is my graph of f. Not terribly bad, it's just got a lot of steps to it. I like these graphs, they're fun. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.